In this video, I'm going to jump around a little bit. I'm going to talk a little bit about wiring electronics, remind you guys kind of how a breadboard works, and then talk a little bit about code as well. So if you might recognize this from last week, and something that really threw off a bunch of students when we were putting together this breadboard was that these three wires were lined up in a row, okay? When in reality the switches we used had spacing in between the legs, okay? Which means that these wires would have needed to have spaces between them. And it actually created some problems because if you had wired it incorrectly, it would have connected this black switch, this black wire right here, the ground, to this middle leg, and the high switch, the high voltage switch side, to this leg. And if you do that, you're effectively shorting out the switch, which would which caused it to short out and to get really hot and could potentially damage the switch. So my point in saying this is that be careful when you're wiring circuits not to focus so much on the location of things, but how they're connected to the different pieces, okay? And so just a reminder, each of these rows is only significant when things are plugged into it. And anything plugged into one row is connected. So these two things are connected. This is connected to that. This is connected to that. These two things would be connected whether they're in this row or they were in this row. Okay? And so the same thing here. This yellow wire is connected to that yellow one. The red one here is connected to this leg of that capacitor, which is connected to that red one. And this black one is connected to that leg of that capacitor, which is connected to that black one. Okay? Even when you look at this row right here, it doesn't matter where on this row it's connected as long as it's in that row. Okay, and same thing here. There's three wires in this row, they're all connected together. Something you want to be careful about when you're hooking up right here, remember that this red rail represents the high voltage, the +5, so you would want to make sure that that's getting connected to the 5 volt, whereas this blue one represents ground, okay, which connect to that ground one. This is another issue that I saw come up a few times this last week. Those are the things you got to be really careful about, because that is something that shorts out the board and again cause things to heat up and stuff. So just when you're plugging those things in, make sure you understand what you're connecting things to. Okay, these diagrams aren't to copy, they're to use as a guide. The next thing I want to mention, we're going to be building some more complex circuits, and some things that we got to think about is again how things are plugged together. And also now we're going to start looking at a lot of different kinds of resistors. Okay, so if you look at this circuit right here, it actually has several different resistors in it, and you look at the colors, they're colored differently. It might be a little bit hard to tell which is which, but the fact that they're different is significant. Okay, the reason I'm pointing this out is because so far we've really just focused on using one kind of resistor, which was this one. Then recently we added in this other kind. Okay, but now we're going to have 3 different ones or 4 different ones here, and it's important that we know which is which and we distinguish them. Okay, remember from early on we said that these stripes represent different values. Okay, and so as we're looking at this, I want to talk about this circuit, because what it does is this is a circuit that allows you to take decisions from multiple pieces and collect them all in one pin. Okay, and this is really useful for something we're going to be making this week. We're going to try to construct a piano. Okay, and so we want to take these 4 pieces and funnel all that information into one pin. Okay, and it's going to give us a range, and based on the value we read from this pin, it's going to tell us which of these buttons is pressed. Now the way that we can do that is that if just this button is pressed, the current is going to go through this button, come down through this chain of wires, and come back through here. And so this pin right here will read that and decide, basically give a reading based on that specific pin. If this one's pressed instead, then the current is going to come through this resistor, and given that this one is more resistance than no resistors, then it's going to have a smaller current, which means smaller voltage reading. Okay, and this next one should be even smaller and smaller until we get to this last one. Okay, and so basically each of these is going to give a different version of that analog reading, remember they go anywhere from 0 to 1023, okay? And pressing these pins differently is going to make a difference. But so the reason that I was talking about wiring is it's really important to understand what's going on. Okay, these buttons each have 2 pins on the side, and what we care about is not where all these pieces are lined up. It's that, like for this button, one pin is connected to the positive rail, the other pin is connected to this wire that connects to the second pin of all these buttons until eventually it's connected to that resistor there. Okay, and then for this button right here, we've got this second rail connected to this wire coming from the first one, and this wire going to the second connector on the second one, or the third one, and then instead of being directly connected to the positive rail, it's got a resistor there. Okay, but if you were to connect the resistor, say, to this pin right here, then it wouldn't work because it's not actually connected to that leg of the button. Okay, and so what matters is that this is connected to this, not that it's in this specific row right here. I'm also going to mention a couple different components we're going to start looking at. So this component right here is a speaker. Okay, it's not quite the traditional speaker, they just call it a buzzer. They're pretty cheap and they can make pretty loud noise, which is pretty exciting. And then this piece right here is called the photoresistor, and what it does is it basically changes its resistance depending on how much light is hitting it, and so we can use it to kind of sense light. Now I'm going to kind of talk about 2 programs that we're going to look at. Okay, so for this first one right here, this is a program that uses the light sensor, the photoresistor, to control the output on the speaker. Okay, and then I'm not going to go through the whole program, but I want to point out a couple things. Okay, first of all, in the setup loop itself, or in the setup function, before we even start the program, it runs this loop. Okay, and what it does is it waits 5 seconds, and during those 5 seconds it's going to take readings to see the highest and the lowest value, and it's going to basically calibrate the sensor. And the reason why is if we're trying to control something with light, it's helpful to calibrate what the ranges are so that the program works. Okay, and so during this time you would be kind of waving your hand in front of the sensor so you can show it what the brightest it's going to see is and what the darkest it's going to see is. And then the program itself, the loop that continues to run after that, is really simple. It's going to take a reading from that sensor using the analog read function, and it's going to map that between those values we calibrated. So we said that we have the low value and the high value we got by calibrating our sensor at the beginning, and we're going to compare this sensor value to that and assign it a value between 50 and 4000. Okay, and once we do that, we're going to go here, and this function is all it takes to play a tone on the speaker. We're going to, this right here is the pitch, this right here represents the pitch number, or the pin number that it's connected to, and this right here tells you how long we're going to play it for. Then it waits and checks it again, and it's just going to repeat that process over and over. And then this right here is the program that we would use to make the piano. Okay, and so a couple of things I want to point out here too. First of all, we have a new kind of variable. This variable right here is called an array. And an array is a list of values. Okay, and we reference those values. The first value located here is called up using the number 0. The next value is called up using the number 1, then 2, and then 3. Okay, and so this is really useful because if we have a bunch of things that we want to keep together, it's very useful to store it as this kind of variable called an array. Okay, and so here, to control the piano, we're going to read what the button says when it's pressed. Okay, and then if that value is equal to the highest possible one, it's going to play the first note. Then if it's not, it goes to the else. Here's a situation where if you want to make a decision between a bunch of options, this is what you do. So after it goes to the else, it's going to check again. So this is called an else if. Then it's going to say, well, if it's not there, then if it's between these ones, do this. And if it's not between those, check but if it's between these and do this. Or if it's not between those, do this. Then if it's not between any of those ranges, we're just going to do this instead. Okay, and so this is how we can choose between really 5 different options by this chain of if and else. And you can make this chain as long as you wanted to, depending on how many notes that you had. Okay, so if you wanted to add a few more switches in there and make your song more complex, that's something that you could do. Something I think I forgot to mention, these numbers right here represent the frequency of the sound. Okay, and so the note depends on what frequency is being played. As you build your keyboard and you want to try playing a different song or different notes, try changing these numbers to see how it changes the sound. These numbers for the frequency of the music or the frequency of the sound.